Hello everyone, welcome to SISYA class. So we are going to study about the chapter electricity. So first thing first, what is electricity? Electricity is the flow of electrical charges. As we know in this universe, basically there are two types of charges. One is positive charge that resides in protons, right? And another is negative charge that resides in electrons. Okay? So whenever electron flows through a wire, electricity gets conducted through it, right? Or we say the electric current flows through that particular wire, right? So whenever the electric charges flows, electricity is generated or electricity is produced. Electricity is produced because of the flow of electric charges. So it is a form of energy that can be controlled easily. How? You must have switched on your let's say bulb. You came to your home, went to your room, you switched on your electric bulb, then your electric bulb starts glowing. So how you are basically controlling the electricity? So you are controlling the electricity using switches. Got it? You are controlling the electricity of fan. When you switch on your fan, your fan starts moving. Why? Because you can control the electricity using switch. So it is the form of energy that can be controlled easily. Got it? It is found everywhere. In today's era, we cannot imagine ourselves without electricity. For example, your mobile phone. It gets charged because of the electricity. Your fan, your light, your electric bulb, your home appliances, your laptop, all the things works on electricity. Right? If we were in Stone Age, then we were not able to say that we are basically completely rely on electricity. But we are in modern era where electricity play a very crucial role. Okay, so electricity provides us light, electric bulb. That is a good example of it. Heat during the winter season, there is a heater which produce electric heat, which using electric energy to produce heat to keep you warm in winter days, right? Another thing is motion. The motion of electric fan. When you switch on your electric fan, your fan starts moving in circular motion. Your blades, fans of the blades starts moving in circular motion. So this is the basically conversion of electrical energy into mechanical energy, you can say, right? Another way is communication. Your mobile phone, telephone, they all work on electricity, correct? So now let's talk about what is electric current. So for example, if you have an electric wire, so electric wire must have some dimension or some cross-sectional area. Means it must have some cross-sectional area. Means if I basically place an imaginary ring around that around the wire, then I will when I put out the ring from that particular wire, then I will see there is some circular area there, correct? So that is called cross-sectional area. So as we know, the electric current is basically flow of electrical charges. So whenever some amount of electric charges flow through that cross-sectional area, the imaginary cross-sectional area I'm talking about. Imaginary means just put basically imaginary ring around the circular wire, right? So that will be your cross-sectional area. So the amount of electrical charges basically passing through that cross-sectional area over a time is called electric current. It is simple as that. Now let's see its mathematical form, basically how we define in mathematical way, right? Let's say this is your wire and you have imagined a cross-sectional area like this. So there are electrons are moving in such a way that they are passing through this cross-sectional area, right? They are passing through that cross-sectional area. Since electron is the electrical charges, and when electrical charges move, the electric current is produced. Okay, so let's say there are q amount of electrical charges flown through that cross-sectional area over a time period of, let's say, t. So how we will define current? We define current with word, or you can say by the symbol capital I, right? So the amount of charge which has flown through that cross-sectional area is q, and the time taken to flow these q amount of charges through that cross-sectional area is the time taken here is t. So this is current I is equals to q by t. And its unit is ampere. It is denoted with capital A. Got it? So it is denoted by the symbol capital A. Got it? Now, so its formula is I is equals to Q by T, unit is ampere. Now, what is the unit of that particular charge, amount of charge that is passing through that cross-sectional area? The unit of that charge is coulomb, right? The unit of SI unit of the charge is called coulomb, right? So in 1 coulomb, so basically whenever there is 1 coulomb passing through that 1 second, if I denote, let's say 1 coulomb is passing through that cross section in 1 second, then the current will be 1 ampere, correct? So how many electrons are basically flown through that cross section in 1 second or in 1 ampere current? So in 1 coulomb charge, there are number of electrons of 6.25 multiplied 10 to the power 18 electrons. Means this much amount of electron has passed through that particular cross section in 1 second to produce 1 ampere of current. Got it? Now, the charge of 1 electron is basically 1.6 multiplied 10 to the power minus 19 coulomb. So it's a magnitude value. As we know that the electron has negative charge. So it's a magnitude value. 1.6 multiplied 10 raised to power minus 19 coulomb. Now, how does charges flows? For example, if I say, how does water flow in your home? Basically water flow in your home through the tank, right? The tank which is situated on the roof. So when the water comes from the roof to at your home, basically let's say your kitchen, your washroom, or someplace else, it is coming through the pressure. The pressure or potential energy it has gained when it is at some height. It is coming because of the pressure. The pressure at the topmost place is very high, and at lowest pressure, at lowest point, the pressure is low. Right? So potential is same as that. Potential is kind of pressure that pushes the electrical charges to move from higher potential to lower potential. That's how the electricity gets conducted. For example, here it is a battery, and the electrical charges are moving like this. So electrical charges moving from higher potential, means positive terminal of battery, to the negative terminal of battery, right? Why? Because the potential of a battery. So potential acts as a pressure to move the electrical charges from one terminal to another terminal. That's how electricity gets conducted. So charges basically do not flow by themselves in a conductor like water in a horizontal pipe. Means water can be flown from one place to another place if there is some slantiness on the surface, correct? So water can flow, but electric charges cannot, right? Electric charges only flows because of the potential difference, correct? So here basically the pressure terminology is connected to potential difference. Got it? Clear? Now let's see the other form of potential difference. So potential difference, as we know, it is a kind of pressure that is moving the charges from higher potential to lower potential, that we know, right? Now the amount of work is basically done to move a unit charge. To move a unit charge from one terminal to another terminal is called the work done. Just mark my words here. Work done to move a unit charge is called potential difference. So we have seen the image, right? So the work done to move a unit charge means 1 coulomb of charge, right, is coming from positive terminal to going to the negative terminal. So that's what is potential difference. So in mathematical way, we define it the work done divided by the charge. That's it. Simple, right? And its SI unit is volt, named after Alessandro Volta, who discovered it. If you like this video, follow SISYA classes for more such content. Thank you so much.